Hello guys, this is Mr. Chen. It's been a while. I thought I would still have a chance to meet you all in a classroom this semester, but things like it's not going to happen. Well, this week and next week, I will be teaching here for you. I'm going to talk about the integer operation by a meaningful instruction. So here is the schedule what we will do in the coming 2 weeks. This past Monday, you guys took pretest of integer operation. That won't count as a grade. However, after my 2 weeks lessons, there is a post-test on April 27th. It will count as your bonus point. So today I'm going to go over question 1 to question 8 of the pretest by using meaningful instruction in 2 videos. Question 1 to question 4 are integer additions. This will be in the first video. And question 5 to question 8 are integer subtraction, will be in the second video. And next week, I will go over question 9 to question 16. They are integer multiplication and division. So the post-test on April 27th, the test questions will be the same as the pretest, but the numbers in the question will change. The most important thing, this post-test is the last chance for you to get bonus points for this semester. I hope you guys can grab this last chance, especially for those who did not do well on midterm. This is a good chance for you. Moreover, this lesson content is also included as a part of research. My current research is to find out pre-service teachers as you guys. You know your knowledge of integer operation, which includes to find out your procedural knowledge and conceptual knowledge of integer operation. So here is the definition of meaningful instruction. Meaningful instruction is using concrete concepts which connect to your real life to represent the meaning of numbers and algorithmic signs. This instruction aims to improve learners' conceptual knowledge of mathematics. Here we use meaningful instruction to interpret integer operation. This week, I will teach 3 meaningful methods for addition and subtraction operation. The first one is charge field model. Second one is number line model. Third one is pattern model. I will introduce how to use these 3 models by going over pretest questions as examples. Some of you guys may have learned the similar content in Dr. Lin's CI-389. I think this is a good chance for you to review these methods and do more practice on it. Okay, so let's get started on reviewing the pretest. This is question 1 from the pretest. So basically, this question tests learners' procedural knowledge of integer operation. So I think this question is not going to be a problem for you to find out the answer. So 4 add -2 is the same as 4 minus 2. The product is 2, right? So here we explain the concept of this procedure by the complete sentence. 4 add -2 is 2. It's because we think that adding -2 is the same as -2. Therefore, 4 minus 2 is equal to. So this is an example I use a complete sentence to explain the above procedures. For this kind of question, you can just write down like this example for receiving the full points. And again, this is not a problem. This is not a problem for you to get full points, right? Okay, the point in this instruction is for like this question 2. Okay, so basically question 2 is asking learners conceptual knowledge of integer addition. So the point in this question is asked, how can we explain why 4 added -2 is equal to? So we have to use the meaningful methods to provide approaches for kids to understand why it is like this, okay? So let's move on. Excuse me. Okay. So the first model I'm going to talk about is charge field model. The concept of this model came from the electric charge. So this model can apply to the addition, subtraction, multiplication, and division. You can use this model to explain all the concept of these four situations. As I say, addition, subtraction, multiplication, and division. And there are some rules for using this model. Okay, so first, one positron to represent +1. Okay, one positron represent +1, and one neutron represent -1. And second, the plus sign for the algorithmic purpose means adding something into a field. The minus sign means take something away from a field. So here's a field. When the minus sign means takes away, for example, here we take away neutron from out of the field. And plus sign means add in, so here we add in a neutron into a field. And also we all know the one positron and one neutron placed together will actually cancel out each other, so it will make the field neutral. Okay, so like this, when these two things are together in the same time, they can cancel out each other, so the field will still keep the 0. Okay, there's no any charge in the list field right now. So let's use the question 2 as an example for this method. Okay, so first of all, I will write the equation to the form of the +4 add a -2 is +2. Okay, and then we start from explain +4. So +4 here means we have 4 positrons in a field. We have 4 positrons in a field. Okay, and -2 means we have 2 neutrons out of field. And add here, according to our rule, plus sign means add in something from out of field. Okay, so we add in 2 neutrons into a field. Okay, we add 2 neutrons into a field. And the rule another rule, one positron and one neutron placed together will be neutral, right? So according to this rule, here we see we can cross out 2 positrons and 2 neutrons. When they cancel out, what left in the field right now? So actually, right now the field, there are only 2 positrons left in the field, right? And one positron represent +1. So 2 positrons represent +2. So that would be the answer. Okay. So this is a example to interpret why 4 plus negative 2 is 2 to kids by using a charge field model. Okay. In this example, you can see every element in the equation here. In the equation has been provided meaning, which can help kids to understand those algorithmic concepts. Again, we are not asking kids to use this way to solve a math question during the test. But actually, this method is to help them to understand how integer addition here, okay? Okay, let's move to the method 2, number line model. These concepts came from a car's movement on number line. Okay, you guys all should know what the number line is. Okay, and this method can apply to addition, subtraction, and multiplication. And again, there are some rules for using this model in addition and subtraction. So as I say, we track the car movement on a number line, right? So the car will always start from a 0 position like this. This is the first rule for using this model, okay? And the sign that comes with number represents to the direction to that the car will move. So the positive sign means that the car will move forward, and negative sign means it will move backward. So for example here, positive 4 means the car will move forward 4 units. And then negative 4 means the car will move backward 4 units. Okay? And the third rule, the algorithmic sign represents the direction that the car faces to. In the addition sign means the car will keep face toward the same direction as the original. Whereas the subtraction sign means the car will switch to face the opposite direction. So here is example. Here we have a car here, right down here. And the positive sign means the car will keep the same direction. It won't change. Again, this sign, this positive sign is algorithmic sign, okay? Don't confuse with the sign come with number like positive 4 or negative 4, the example we just mentioned. And negative sign here means the car will switch to face opposite direction. You see that? The car just switch the sign to the opposite direction. Okay, so let's move on to the example. So the same question 2. Here we use a number line model to explain. So first of all, car will start from 0. So you see the car start from 0, right? And so second, positive 4. That means the car will move forward 4 units. So right now we move forward 4 units. So the car right now start at the 4 position, right? Positive 4 position. And next, plus sign. The plus sign means the car will keep the same direction, right? That's the third rule. So we do nothing here. The car will just stay there, okay? And next one, negative 2. So negative 2 here means the car will move backward for 2 units, okay? So now you see the car stop at the positive 2 position. And this is the final product as we have for this equation, okay? Positive 4 add negative 4 is positive 2, okay? So personally, I really like this model because it's very clear and easy to understand. So for me, I will use this way to explain this equation, the meaning of this equation to kids. All right, let's move on to the third model, the third method, pattern model. So this is a concept from a reasoning of operating pattern. It can be used to explain addition, subtraction, and multiplication. Okay, but however, use this model, there's a requirement is learner have to have previous procedural knowledge of integer operation. So they have to know how to operate integers. Okay, so let's use example to introduce this model. Okay, so we assume kids knew how to operate a positive at a positive, but they don't know how to operate a positive at a negative. We use this method to interpret it. Okay, so we knew 4 add 2 is 6. That's the positive add a positive, right? And we know positive 4 add a positive 1 is 5. Positive 4 add 0 is 4, right? So here we found a pattern. Did you see that? Okay, by this animation, you can see the pattern we found is when product decreased 1, while addend decreased 1, a product will decrease 1, right? So addend here, when every time addend decrease 1, the product here will decrease 1 and decrease 1. So we know 4 add a negative 1. So addend here is like decrease 1 from 0, right? So the product will be 4 decrease 1. So that will be 3, okay? So back to our question, 4 add negative 2 is the product will be, because again, the addend here decrease 1 from negative 1, so the addend here is negative 2, right? So the product, they also decrease 1 from 3 to 2. So the final answer for this is 2. And this is the evidence that y 4 add negative 2 is the same as 4 minus 2, because the answer is the same. This is how we introduce this concept why when a positive number add a negative number is the same as a positive number minus a positive number. Okay, that's how we use this model to introduce this kind of concept to kids. Okay, so let's move on. This is question 3. So again, it's pretty familiar. This question is asking the learner's procedural knowledge of integer operation. Okay. So again, that won't be a problem for you. So here I will just show you the answer, my answer for this question, and I will upload this PowerPoint up to D2L. So actually, you can download this full PowerPoint. So don't worry about if you cannot, read clear of all the information in this PowerPoint in my video. So let's move on to the question 4. This is the point we focus on, this meaningful instruction. Okay. So for question 4, this is test the learner's conceptual knowledge of integer addition. And we want to interpret the meaning of negative 4 add negative 2 is negative 6. Okay. So again, we better use the charge and field model. So for this question, we start from negative 4. Okay, so negative 4 means we have 4 neutrons in a field. 4 electrons in a field. Also, we have -2 means -2 electrons out of field. 2 electrons out of field. Okay. So, and add means, again, that's the rules. Plus sign means add in. Okay, so we add in 2 electrons into this field. So how many electrons in the field right now? There are 6 electrons in the field. So the answer is represent -6. Okay, this is pretty simple for this kind of negative plus negative. It's kind of pretty simple by using pretty simple to explain by using this model. Okay, all right, let's move on to number line model. Number line model, again, curve start from 0, as you can see from animation, and -4. -4 means car will, sorry, there's a typo here, but this is correct. So rule, negative sign here means that the car will move backward for 4 units. Okay, again, this is typo. This should be backward. Okay, so car right now move back to the backward for 4 units. So the car right now, the car start from 0. Again, I show the animation again. It's car start from 0. And car right now move back to the for 4 units. So the car right now start at -4. Okay. And the plus sign means the car will still keep the same direction. So we do nothing here. Okay. But we will have to do something when it's a minus sign. Now, we will show this thing in the second video because that's about the subtraction of the integers. Okay, so here right now we still keep the car in the same direction. We do nothing here. All right, and the -2. -2 means car move backward 2 units. So this time there's no typo here. The car will move backward for 2 units. So car move backward for 2 units. You can see the cars right now start at 6 and -6, right? So where the car stop at is the final product for this equation, right? So like I said, I really like this model because it's always make everything pretty simple to introduce the concept. All right, let's move on to the last model for addition, pattern model. It's question 4. Okay. So we assume kids knew how to operate a negative at a positive, but they don't know how to operate a negative at a negative. We can use this method to interpret it. So we knew -4 added +2 is -2. Okay, again, kids know because they know why it's a negative add a positive, right? So negative number add a positive number, and in this equation, the product will be -2. Okay, and then we know -4 added 1 is -3. -4 add 0, the product is -4, right? So again, we found the pattern here. So the pattern we found is every time when addend decrease 1, when addend decrease 1, the product will also decrease 1. Okay? So when addend decrease 1, the product will decrease 1. All right? So we know -4 add -1 is, so we see the negative 1 came from 1 from 0, sorry. So here is the same thing, it decreased 1, right? Addend decreased 1 right now. So the product, the same, we will decrease 1. So the product here will be negative 5. So back to our question. Our question is negative 4 add a negative 2 is, so we can see the pattern here again. When addend decrease 1 from negative 1 to negative 2, the product will decrease 1 as well. So the negative 5 decrease 1 is negative 6. So the answer for this equation is negative 6. All right, the first video will stop here, and you will keep watching the second video for subtraction of integers. Okay, I will see you soon.